Okay, in the two previous examples involving roots, when we plugged the number in, it didn't give us anything undefined. We didn't get an even root of a negative number, or we didn't divide by 0. However, this one, if I plug the 0 in directly, that means I am dividing by 0, so we have another undefined situation. That means that we need to do some kind of manipulation to this one in order to get the answer. So, we haven't looked at this one yet. This one has got two different roots. What you're going to do on these kind of problems in order to get rid of that is you're going to multiply the top and bottom by the conjugate. So conjugate is the same exact thing you see on top, except that we're going to have a plus sign in between. We're actually going to form a difference of squares, because then that's going to allow us to eliminate a radical from the top. Now you will get a radical on the bottom. That's okay to have a radical on the bottom in this case. It's going to allow us to cancel something, hopefully, and we'll be able to plug the 0 in, and then we won't have a division by 0 happening. Let's do that in this one. So we're going to go ahead and I'll rewrite this, so that way you know what the original question was. And then what I'm going to do to this is I'm going to multiply top and bottom by the square root of 2 plus x, and then plus root 2. And I'm going to do the same thing, top and bottom. Okay. Whenever you're multiplying one side of an equation by something, you can't just put this over 1. The reason why is because if you just arbitrarily multiply it by something, it's going to change the original problem. So we need to make sure if we're just multiplying one expression, there's no equation or anything, you're just going to multiply top and bottom by the same thing, or multiplying by a power of 1. By doing that, we're now going to FOIL this one out, and that's going to take us down to the next step. Now, on the bottom here, I'm not going to distribute that. I'm going to keep it in the factored form, because again, a lot of times with these you'll be able to cancel something out. Okay, so in this case, nothing I can do in the bottom except just to write both of these multiplied together. Now on top, I'm going to FOIL this. So I'm going to take this one and this one. Now when you already multiply two radicals together that are exactly the same, the radical is going to disappear, and we're just going to end up with 2 plus x. The reason why, if you multiply this times this, you get the quantity 2 plus x squared, and then we're taking a square root, which will cancel it out, and that's why you just end up with whatever you have on inside the root. Then we do the next one. Okay, so I'm going to do these two multiply, and I have these two. The middle terms are going to cancel here. I get a positive root 2 times this one, but I get a negative root 2 times this one. Those middle terms are both going to cancel, and that's one reason why you're always multiplying by the opposite sign, because you can get those middle terms to cancel because you're using difference of squares. The last one is I have a minus sign, and then I have radical 2 times radical 2 is going to be radical 4. Square root of 4 is 2. Okay, so in that case, when I multiply everything on top, this is all I'm going to end up with. So here's what happens. Once we get that multiplied out, we notice that 2 and negative 2, those are both going to cancel. Okay, and so the x's here, those are going to cancel out as well. So if I were to write this out, I would get the limit x approaches 0 of x over x, 2 plus x plus square root of 2. Okay, so I end up with this. The two x's, you can cancel those out. Now if you cancel those out, there's still going to be a number on top here. A common mistake that I see is people cancel out that, and then they'll just write this as the answer. It's not this. There's going to be a 1 in front of it, because again, x over x really reduces to 1 over 1. So if I cancel it out, there's really still a 1 that's there. So now I have the limit as x approaches 0 of 1 over 2 square root of 2 plus x plus radical 2. So now, if I were to plug a 0 in here, I'm no longer going to get a division by 0 situation happening. I can plug 0 into this one. That would give me 1 over radical 2 plus 0 plus radical 2. And then what will happen is this just simplifies to radical 2, and I'll get radical 2 plus radical 2. I'll get a 2 radical 2 on the bottom, and that would be the answer. On the tests in my class, you don't need to worry about rationalizing this one. If you are doing those online homework systems, it may require you to rationalize that before you plug it in as your final answer. So you would just multiply top and bottom here by radical 2 over 2. So if you did that, then you would get a 4 on the bottom, because you get 2 times radical 2 times radical 2. That would be 2 times 2, give you a 4. So Again, on tests, you don't need to worry about rationalizing it, but in those online homework systems, they may require you to have your answer as an exact one, so you can write it as root 2 over 4. That would be the exact answer. Okay, so here's another one involving fractions with radicals. First thing you do with these kind of problems, you always want to plug the number in to see if you get division by 0. That'll tell you if you need to do more algebra on this or not. Put 3 into here. 3 plus 1 is 4. Square root of 4 is 2. 2 minus 2 is 0. So yes, this is one where we do have a division by 0 situation happening. Okay, so that means that we have to do some algebra on this. The technique for these kind of problems, you'll multiply top and bottom by the conjugate. Now it doesn't matter if you got the radical on the bottom or if you have it on the top. We're still going to multiply by the conjugate, top and bottom. The conjugate of this would be this with a plus 2. So top and bottom here, we're going to multiply by the conjugate of this one. So let me rewrite this. And we're going to take this and multiply it by the conjugate. The conjugate is the square root of x plus 1 plus 2, top and bottom. Okay, so that's that step that you're going to be applying here. You're multiplying again, top and bottom, by this conjugate. Minus 2, it's going to be a plus 2. When you have this across the top, I'm not going to FOIL all this out, and the reason why is because a lot of times when we multiply the bottom, we'll end up being able to cancel out this part on top. So that's why when I rewrite the top here, I'm just going to leave it alone. So I'm just going to write it, keep it in the factored form in this case, and then when I do the bottom one is going to be a FOIL. So I do want to multiply this one out because again, it's different squares, you're going to get some things to cancel. Okay, so the first thing we're going to do, we're going to multiply these two things here. When you multiply that, you get x plus 1 on the bottom when you multiply both of those. You get a plus 2 and a minus 2, which is going to cancel. And then you're going to get minus 2 and a plus 2. You're going to get a minus 4 on the bottom. So again, these two things, when you multiply them, the radical disappears and you get that. And then when the middle terms cancel and then you get minus 2 times plus 2, you get a minus 4. Now, what will happen here is you can do some simplifying on this and canceling. What will happen is you have this, the top part is still going to be exactly the same, but the bottom one, you get an x minus 3 happening there. And so now we notice that we get the same thing on top and same thing on the bottom. That allows us to cancel that out completely. And so what's left over is something where we don't have a fraction anymore. So I can plug 3 directly into here now to get the answer. Square root of 3 plus 1, and then I have plus 2. This gives us square root of 4, which is 2, so I get 2 plus 2, which will be 4. So the answer for the whole entire problem is going to be 4. So again, this is the y value that it's approaching when x is equal to 3.